Monica, I don't know if you can hear me.
Yes, yeah. We can hear you, but your screen is okay. Maybe you're sharing on the slides. Huh?
Yeah, I hope everybody can see the screen. I hope now you can hear me and you can see the screen also. There was a slight problem with both my earphones and my Bluetooth devices. The other day we were dealing with the back titration, and then we just introduced a little bit of the redox. But today I'm changing kidogo. We are still going to talk about the titration process. But now I wanted us to deal with the practical sessions. Actually, really, they're just practical skills, what you're expected to do when you're doing a practical. I'm well informed that we are going to be having a practical, I think, at the end of the month. So these ones are the skills that we might be using. I'm also hoping that there is kunataka kunyesha huku, so I'm hoping that the rain will allow us to move a little bit so before it starts, hopefully. So we can start now. I don't know if Abdi is in. I saw Abdi coming in and then I don't know what happened. He's not in yet. Huh? So we can just proceed in the meantime as we wait for him. I saw him, then disappeared. So practical skills. So today we are basically talking about the practical skills. I'll try and zoom out so that it can be. Oh, we just fit the window. It fits the window. Just zoom to 100. I think we can use 100. That one is okay. Yeah, I think that one is clear. So we can continue. Now, when you go to the lab, of course, this one now we are not talking about the quantitative skills, the ones that we did. Now the filling of the table, I think kila mtu alikuwa amekuwa sawa kidogo, although I said again, Abdi had texted me that akuwa amelewa kitu kidogo, which I was like, it is okay. I think we still do something on that because we are not yet completely done with that topic. So we are still remaining with redox. We have something to talk about atomicity of gases and the rest. So we'll still come back to the filling of the table. Now, my interest in this one is actually the qualitative. The practical that you're going to do, the first section or question number 1 is what we did. Hiyo maneno yako, you use a burette, you transfer, you just follow the procedure until now you have the endpoint, you get everything that you need. You fill the table, you calculate the depending now. If it is a direct titration, it should be easier. But if it is now the back titration, you'll have to calculate the RAMs and the rest. Which I'm hoping that the questions that you're going to do will have that one because you have done several of those ones. Of course, we'll still do more if time allows us. So when you do the qualitative analysis, now this one is the second part or the third part of the question. Now, there are some things that you're normally asked. Now, whatever I've just placed on the screen is what you're normally asked. They normally ask you, do the following. Eat a substance. Now, when you eat a substance, you are supposed to say, what happens to that substance? I'll give you how to answer those questions. And you're supposed to be very, very keen. Sometimes they're telling you, add a substance to another. I'll give you an example also. They can say add HCl to something else. So those are the things that you're supposed to do. Now, some other questions as you start, they will give you a sample. They'll give you something. They tell you, please transfer that thing to a test tube or transfer that thing to a watch glass, depending on the question. And then they ask you to describe that sample. So you're supposed to describe what you see. Now, the other time when we were dealing with the filling of the table, I was very particular and I said, it is very, very unsafe to copy from somebody else, especially when you're doing the practicals. Now, practicals actually answers are different, and there is a way of filling of answering those ones. The only thing that should be the same, especially when you're filling the table, iteration, is the number of decimal places. For example, if you get 16, you don't write 16. You write 16.0. Those are the only things that should be the same. That means Monica, Abdi, Maura, you should be having 16.0. Maura akona 17. What we need is point that decimal place. That is what I need to see. So they should be the same. That is the only thing that should be the same, or that should be in the practical. But the answers could be different. And I said previously that your answers, as long as you have two things or two, what can I use? I'm looking for that word. Values. Let me use values. Two values. As long as you have two values that are close to each other by plus or minus 0.2, then you're good to go. And of course, the value should be realistic. That is what I said. So I think we'll repeat on that one again. So you usually ask the following. I think I'll share this PowerPoint so that you can go through. But for today, let me just discuss it. I'll still share in the group. So what you download it. This one is PowerPoint. It's just tailored for the Form 4s. Actually, this one is only I normally use it for the Form 4s alone. I don't use it for the other students because they'll get confused. Now, so what you do now, you must be very alert. That is why I'm saying, ukienda kufanya mtihani, especially the paper 3, you are not supposed to be thinking of other issues ya nyumbani. Zile wachana na vitu za nyumbani for the only 2 hours that you need. So 2 hours wachana, sahau vitu za nyumbani. It is very dangerous. Not to now observe the following. Now, you should check on the change in the color. Some of them are normally white, and then they turn to blue, or they were colorless, they change to green, they change to any color that comes in. It is very important because actually that is the observation. Any color change is an observation. Now, another thing that you can see is normally production of gases. It is visible. Actually, it is visible. It is like, let me just use this example so that people understand how visible it is, man, gases. How gases are normally witnessed is hata nyumbani ukiweka sukari kwa uji. Let me use uji because I think that there is bubbles that normally come out of the porridge. Kwa uji kuna hiyo bubbles zinatoka. So that one means there are gases coming out of that sugar. So you unaona kama kuna bubbles kwa the liquid that it was not there before you introduce something else. That means there is production of gases. Now we'll talk about taste of gases. Here too, there is taste of gases. We'll talk about maneno ya color changes. We'll touch on that. Now, something else is formation of the white precipitate. I'll use this example. Very easy example. When you are cooking ugali, na uamue kuongeza unga kidogo. I don't know the idea. I don't know how our parents do that. I don't know. I also see them doing that at home. I don't think it works, by the way. I think when people, if you study chemistry, you'll realize that thing is not working. Hiyo ya kuongeza unga alafu ifanye nini ichemke haraka. It is in Form 1 factors affecting how impurities affect boiling point and melting point. So you'll check. I think it lowers the melting point, but it raises the boiling point. So I don't know what they were trying, but we don't talk about that today. So formation of a white precipitate, I was talking about that. So I'm saying Maneno ya precipitate ni ukiweka unga. So if you introduce something and then you swirl and it doesn't form a colorless liquid. And a colorless liquid, I normally use an example of water. It will form kitu misty, something that is misty. Kama maji yenye imeongezwa unga kidogo kwa umbali, or let me just say this, it was clean water and then it turned dirty. Hiyo ikichafuka sasa, that is a precipitate. Yani maji sio clear tena venye ilikuwa. Let me just use that one. It is not as clear as it was when you started the experiment. Now you say that one has been the information of a white precipitate. Yani kama imechange, slight changes. That is why I wrote, you must be alert. You must be alert when you're observing those ones. Now we continue very slowly. So I'll just be clicking the next PowerPoint. You should not be worried. If you don't get something, you just check. Just check with me. So I have to zoom this one out. Let me check if this one can zoom. Yeah. So I'm saying I'll still share this one. I'll still share this one with you after. So I want to check if we can. I can zoom out more. I don't know. Okay, I think that one is okay. Let me check if we can. These things, I don't like these ones. Let me check if I can change how we are going to view so that it can be easy. Yeah, I think that one is better. Yeah, so I think this one is better. So I think this one is better for everyone now. I was trying to remove this one. I don't know where I should move this one because now, okay, that one is better. Now, chemistry practical notes. So I'm saying this one is normally very good for the Form 4 because the Form 4s now, especially the term 2 of the Form 4, they have done everything. There's nothing that is remaining for them actually. The only thing that is remaining is for them to sit for the exam and leave because most of us would have completed the syllabus by term 2. Now, test for anions. Test for anions. I'm going to say this. Anions are negatively charged ions, as you can see. Now, all of the radicals that you have been mentioning, radicals zote, the carbonates, the chlorides, the nitrates, the sulfates, hydrogen carbonates. Of course, hydrogen carbonates and carbonates are normally tested almost the same way. The only difference is the other one will produce water, which most of the time we will not see unless the liquid is insoluble, or that is the liquid does not dissolve in water, or the solid is insoluble. So which would have been seen already. So number one, anion, we had a dilute acid. Any acid in that case. Any acid. And then there is effervescence. Now, effervescence, I want to use this one. Now a very good example when I'm giving discussing effervescence, I normally use vitu inaitwaje ya is it constipation or heartburns? Hizi vitu zenye inaadvertisiwa sana. Ino, yes, I was looking for the name. Ino. We normally use ino. Now, ukiweka ino kwa maji, what normally happens? Whatever happens now is called effervescence. Now, and actually that is how it works in the stomach. That's how ino works. You check ino, it does that in the stomach. So it dissolves things. That was not supposed to be there. Maneno ya constipation inaisha and gas and the rest. So add dilute acid effervescence. Now, it normally produces carbon dioxide. I am not going to say how it tastes carbon dioxide because there is something down there that is test for gases. Now, when you check and then you see, or ukiona wamekwambia taste this one, of course they will not give you the name as carbonate. They will tell you I had a dilute acid. When effervescence occurs, that is the observation. Now, when you are giving, they will not tell you that it is a carbonate. When you are giving now the inference, which I'll show you the inference. When in inference, I think I'll give something. There's another note. There's some other notes. I think I'll share with Madam maybe if you will, I was trying to link it for it in my computer. It is not there, so that you see how effervescence or how the inference, how we infer. Yani inference, I can say unafikiria hiyo ni nini. Inferring is you are not sure, but you are supposed to tell us what it could be. That is infer. So you are inferring, you are telling us it inaweza kuwa nini present, yeah, or absent. So effervescence. Now chloride ions, we normally add dilute nitric acid, then add silver nitrate. Of course, you will see that is silver nitrate. So when it forms a white precipitate, sometimes you'll add lead nitrate. Sometimes they add lead nitrate. It will form white precipitate. We'll talk about that one. That one is the observation. Now, the inference is the anion. Yani, unasema chloride ions, which is Cl negative, present or absent if it doesn't form the white precipitate. I'll just guide you on how to answer those ones when we are there. Now, nitrate ions, how we test nitrate ions, we add sodium hydroxide, and then aluminum foil, and then you warm carefully. Ammonium is produced. Now, we normally say ammonium ions, not ammonia. So ammonia is produced. We'll talk about how we test ammonia. Now, sulfates, we normally use nitric acid and then barium nitrate. It normally forms white precipitate. Now, I want now, before I jump to the test for cation, let me just give you an idea of how these ones, how we can infer. Now, how we infer these ones, we normally depend on your idea that you ulifunzwa something in salts called the solubility of salts. Now, in the solubility of salts, we talked about those carbonates that are soluble and those that are insoluble, which we said all carbonates actually are insoluble. Yeah, except the group 1 and the rest. Group 1 and ammonium, that is. Chloride ions, the reason we are adding silver nitrate is because chloride ions actually, silver chloride is insoluble. So is lead chloride. So they are insoluble. So they will form white. So if I add, that is why in Elisema, for chloride ions, we can use dilute nitric. And then of course also we can use, instead of silver, kama hakuna silver nitrate, tunatumia lead nitrate. We still get the same observation, white precipitate. In fact, they will tell you warm. If you warm and the solution dissolves, then you say now it is lead ions, which we will talk about apochin. So when I was talking about the anions, I'm talking about remembering solubility of what? So kitu nataka mkumbuke hapa is this, especially the test for anions. Remember solubility salts. Where jua salts gani as they dissolve, and then know which ones are dissolving. If you know that, of course, it becomes very easy to handle this one. So this one is normal solubility of salts. And also, I'm talking about the salts that we studied there, which is, I'll mention them now. Sulfates, we said all sulfates are soluble except, because I've just touched on carbonates. All carbonates are insoluble except group 1 and ammonium. And then I've said all sulfates are soluble except, I think we have barium, we have lead and calcium, which is slightly soluble. And then we have all chlorides are soluble except silver and lead. Lead has a special case. It is soluble in warm water, but insoluble in cold water. So it was a special case. And then we have which one? Nitrates. All nitrates are soluble. And we are talking about sulfate. So everybody is taken care of. So remember the solubility of salts. That is in Form 2. I'll be just mentioning Form 2. I'll also give you the classes that are in Form 2, and it is a topic called salts. Of course, it goes without mentioning that I even thought these are the salts in Form 4, and it is in topic 1 in Form 4. So in topic 1, Form 4, we still get the same thing. Now in Form 4, we don't even talk a lot about salts, but it is in Form 2 sana. Hiyo ingine inakuja. Now, how do we test aqueous ions, cations? Now this one is in Form 3. This one is a topic in Form 3. I'll still give you where it is. This one is a topic in Form 3. I think it is done twice in Form 3 and also in Form 4. And in Form 4, we normally do in acids, bases, and salts. When we add sodium hydroxide or adding ammonia solution. So it is the same thing. Now, you're going to prepare for the practical. Now, when you are testing ammonia, of course, ammonia ions mostly are not there, but we must mention it. Yeah, we mention it because it is a cation. And we are talking about cations. Now, cations are positively charged ions. Anions are negatively charged ions. Let me just show you before I move so that unaona yote negative hapa. It is negative. It is negative. So yote ni negative. And then cations now are positive. You can check. Most of the cations, actually, I normally say most of the cations are metals. Most of the cations are metals. So most of the cations are metals, which is very important for you to remember that. Most of the cations are metals, except ammonium ion, which is normally a special case. So what? Now, this cation, we are testing this cation. Now, what happens when you add sodium hydroxide until in excess? They will tell you add sodium. We will do an example. Of course, now we'll do an example, which is a dry practical. We will not know. We'll just assume so that I can show you what we mean by inference, because that is what I'm interested in. You understanding the meaning of inference, to infer something. Now, when you add sodium hydroxide to a salt or something, a substance that contains ammonia, there will be a production of a gas. Now, we'll talk about how we test ammonia gas. So don't be worried. Calcium ions, when you add sodium hydroxide, you will say it forms a white precipitate. If you add excess of sodium hydroxide, still there will be no effect. That means it is insoluble in excess. It is very important now in the observation. Listen, hizi vitu nimeandika hapa. Now let me just circle it. These ones, these are the observations. These are the observations. This one is something that we will be saying now. What did you observe after umeongeza? I don't know, it is starting to rain. I hope we even complete 1 hour before. You can still hear me though.
Yes.
I'm trying to use the Monica.
Yes,
I'm still
teacher.
here.
Yes.
Why can't I hear people talking and they can hear me? I'm still finding that one very hard. But I think that is why I was saying, I think there's a problem with my audio. I think if you can hear me, let us just continue for the meantime. If you cannot hear me, you can do it in the chat. So I'll have to move this one. Now, but before that, let us just continue. Kama munanisikia, the better. Now, I have a problem. So let me check if I think it is my headphones, microphone. But it is the same, no? Okay, no problem, no problem. Let us continue and then I'll check that one when we are done. Now, so in nimesako the observation. Now, what you will be inferring, sasa ukisha observe unasema inaweza kuwa nini ndo hizi. That is why I was saying this one, I don't use this one to teach from 3s and below. I use this one to teach the older one because they already know what they are doing. Which now, in this case, we are the older ones. Now, so when you add calcium ions, when you add sodium hydroxide, it normally forms a white precipitate which is insoluble in it. Now, if you add copper, if you add sodium hydroxide to copper ion, it forms a light blue solution which is insoluble in itself. I'll be mentioning some of the colored ions. We have very few colored ions. Now, when I talk about colored ions, white actually is not considered as a color. Yeah, because in physics, it normally disperses to form the, you know what they call the light dispersion. Huh? in light physics, it normally disperses to form the other light, to form the other color. It forms kina blue, kina green, and the rest. It normally forms, let me just, in summary, let me say, it forms the rainbow. Yeah. So copper ions are colored. This one is number one. Now, if it forms green ions when you add sodium hydroxide, and that green ion is insoluble in excess, we say those one is now is ion 2. Now, if it forms when you add sodium hydroxide until in excess, and it forms a red-brown precipitate, please, because NB, before even I continue, please do not write PPT in the exam. Actually, PPT is wrong. It is PowerPoint. The one I'm using now is PPT. If you tell me PPT, Bana, you are wrong. You are gone. You are gone. You are gone. You are gone. So it forms a red-brown precipitate, which is insoluble in excess. If you get that observation, you say ion 3 ions are present. Ion 3 ions are present. Now, if you are testing and it is lead and zinc, I think zinc is normally the same. Zinc and lead, they're normally the same. So it forms a white precipitate, and then when you add excess, it dissolves, and it happens the same in zinc and lead. I'll give you those things. There's something that I think is missing, which is aluminium. Aluminium. But the good thing, I'll tell you something about inferring. Nitaambia kitu kuhusu kuinfer so that you understand. Inferring, we normally advise students to give the positive side, like hour and hour. For example, if you added sodium hydroxide until in excess, it forms a white precipitate that dissolves in excess. Then you can say it is lead and zinc ions present. Now, it is also okay to say it will be correct if you say copper, kama umesahau ni gani zina dissolve in excess, and you remember the colored ions, kina copper, kina iron 2 and ion 3. You can write Cu2 positive, comma, ion 2 ions, comma, and ion 3 ions absent, because you didn't see that color that you wanted. Umesahau. That is why I'm normally say it is easy for people to perform in practical. So kama umesahau zile zenye ziko, you can go with the other one that is not there, and then you say kama unakumbuka hiyo colored ions, unasema haziko, absent, and you still call it correct. Yeah. Now, again, I come back to this one. So this one normally isn't vitu mbili zinatembea pamoja. This one is the observation again, but now we are changing what we are using. We are using ammonium. Unaweza ona ammonia, ama we normally call it ammonium hydroxide. Ukiona imeandikwa ammonium hydroxide, don't be worried. It is the same thing. So utaona imeandikwa ammonium hydroxide. Imeandikwa ammonium hydroxide, or you just find something. It is a base. This is normally a very good base. All of them are bases, but ammonia, I think ammonia is one of the best bases that we have. Now, anyway, so ammonium ions, you cannot use ammonia to taste them, or let me just say, huwezi tumia kitu iko na sukari kuonja sukari. Yeah, you have to need something that, or you can use salt to taste for sugar. So you cannot taste that one. So that is why this one is left out. Now, when you add ammonia to a substance that contains calcium hydroxide, it doesn't form a precipitate. So there is no precipitate form or no color change in. I'll tell you how to answer those ones. So I'm not even going to mention that one now. Now, copper ions. When you are testing for copper ions and they are using ammonia, it forms a light blue precipitate that dissolves in excess to give a dark blue solution. I thought this one in salts. In salts, acids, bases, and solvents from 4, nikasema it normally forms. You remember? I don't know. I have to look for a way to communicate with you. So let me check if it is going to work. So Ed says, I think I'm using the correct one. Let me check. I don't know what is happening. I wanted us to communicate here. So, I don't know if it is my laptop or it is. I don't even know my earphones. I don't know. I have very many earphones. That is why it is bringing confusion a little bit. And I don't know the names. I don't know their names. Uh, yeah, I think it is on my side. I can't hear anything. But if you can hear anything, then it is good. Anyway, I was trying to check if I can. Can you still hear me?
Yes, very well, teacher. Can you hear now?
Yeah, I cannot hear people actually. I really wish I could. Let me try something else. Because I wanted us to have a discussion. I don't know if you can hear me now. Can somebody have say something so that I can hear if you can?
Yes, we can hear you, teacher.
No,
Can you
I
hear
have
us
a
now?
problem. No, it is on my side. I don't think it is on your side. So, because of time, I don't know. Yes, I'm okay with that. I know you can hear me. I have a problem with my side now. That you cannot hear me. Yeah, that is my worry, actually. But anyway, I feel bad that we cannot communicate. But anyway, so I taught this one in this one was taught in assets based on source. That is in Form 4. But there was something that you remember. I said you have what you call a complex source, which the customer it is also called a double source because it has more than uh, one cation or one anion, but in that case, it had two cations, which is copper and ammonium. So it was a complex source, and there are two complex sources that we are supposed to remember. Of course, I think the other one is zinc, so you are supposed to remember those complex sources. So iron too. So we have talked about copper. So copper is special case. Copper forms a light blue solution, which is insoluble when it is in sodium hydroxide. Lakini sasa when you add actuals ammonia na uone light blue pia it dissolves. We don't say it doesn't dissolve. It actually dissolves to form a deeper solution now, deep blue. And that deep blue solution is normally a complex salt, which is normally a double salt. We'll talk about that another time. But we already talked about it, but I know it will be mentioned somewhere else actually in Form 4, so you should not be worried. Still be mentioned. Iron 2, green precipitate insoluble in excess. So it forms a green precipitate which is insoluble. It is a green precipitate, not PPT. Mimi sijakuwa nikisema PPT by the way. I only shortened that one because of so that I don't use a lot of I normally know pia students wakiona very big this one is a summarize notes for Form 4. So mtoto akiona ni wide anaanza kusema "Ai." So that is why I'm using PPT, but when I'm reading, I'm saying it is green precipitate insoluble in excess. Now, iron 2, iron 3 are the same. They maintain their properties, or they maintain the observation both in sodium hydroxide and ammonium hydroxide. So it is red brown, precipitate, insoluble in excess. So we only have 3 major colored ions that we study. Cu, which nimesema, it is blue. This one is copper. So we have copper. We have iron 2. Now, actually, I think people now should write for me. So this one is overly green. And this one is iron 2. Now, and then we have iron 3. And of course, we'll be talking about oxidation numbers very soon. So we'll talk about that. And this one is brown. Now, talking of iron 3, I wanted to ask, can people write for me in the chat? The chemical name of rust. Chemical name of rust. As we continue, chemical name of rust. I'm just giving you a minute each. Chemical name for rust. Chemical name for rust. I know it is a very easy question, but I know people will see fire if they ask. I don't know. I normally feel very bad when people lose marks because they ask something like that. It is normally a Form 4 question. So as you do that, let me work. Let me try make this one work. As you think he has already done something. Monica said iron 3 oxide ferric. What are you saying, Maura? I want to know what you're saying. Now I'm going to stop sharing first of all, and then I said these things so that people can have a conversation with me. So I'm going to stop sharing first, and then now I can connect so that we try. I hope I'm not inconveniencing anybody. So let me just do it for mine. So can somebody say something now so that I can know if you can hear me and I can hear you? Maura, say something.
Teacher, you're asking which chemical name?
So we are back. I don't know if people can hear me very well, but let me check if it is okay. I don't know what is happening. I changed this thing twice. No, it is not working. Actually. It is not.
Monica, teacher anasema ni gani?
Ndio unasema?
Teacher anasema ni gani chemical form nini name ya nini?
Way.
Iron.
Ya iron.
Yes.
Organic.
Okay.
Okay, okay. I don't know what is going on. This is now. How is it now? I don't know. I was just testing something. Monica, I'm very sorry. How is it now? Can you hear me well?
Yes,
I'm
teacher,
trying
we're
to
getting
make this and work.
you.
It is not working. Uh, I'm yet to understand what is going on. I'm yet to understand what is going on with my. I don't know. Am I supposed to disconnect everything first? But I think we'll waste a lot of time if I do that. We'll be just doing it on the chat in the meantime. I thought I would hear people after I did what I just did because I was resetting some of these things. So anyway, I was saying the colored ions, we have three colored ions. So ukiona imeform blue precipitate, usijaribu hata kuandika kina sodium ions, kina nini, calcium, kina aluminium, because those ones are white in color. Na nimesema actually white is not a color because it is normally leading to formation of other color. So we normally say we have only three colored ions that we study actually. And I've mentioned them. We have the gridon, which is ion 2. Now, the reason I was asking, so I had asked about iso. So I don't know. That is why we need the voice, so that I can hear people say something. We have ion. We had what I don't know what Maura is meaning by ferric, because the only thing that is mentioned is ferric. So I don't know what is the meaning of that. So I don't know the meaning of ferric, but I needed to see. Kuna kitu ina miss. There's something missing. I don't know if you see. Yes, Monica. I don't know if you're seeing that there is something missing.
Yes, teacher.
Yes. Okay. I think now I can hear you. So mine had a problem. I've changed using now the earphones. Kumbe vitu za kitambo ni heri kuliko hizi mpya mpya. I was using the Bluetooth and then this one is working fine. The original earphone. Yes, what are you saying, Monica?
I think there's something missing.
Yes,
You told
what
her
is
to.
that?
I don't know. I don't know. Can you tell us maybe?
Yeah, I will tell you. No, before I tell you, Maura, what is the meaning of ferric? Maura, is Maura in? I don't know. Maybe.
Teacher,
No.
yes,
Yes,
I'm
yes.
here. I'm saying, I
Right.
thought that you are asking about the other name of ferry ion 3.
No, no, I'm saying what is the name of rust? Chemical name for rust. Chemical name for rust. It is chemical name for rust. It is a form 1. It is a form something in form 1, eh?
Teacher, can you spell that name?
Rust. Ile. Oh, yeah. I need to spell. I now understand you, Maura.
Eh.
Yeah, I understand. Ile kitu inashika. I know the R is coming in here. And R and so ile kitu inashika mabati. Kuna kitu inashika mabati.
Oh, rust. Hiyo
Rust.
ni. Kutu.
Yes, that one. Kutu. That one. Yeah, I was looking for that name. Kutu. The reason why I brought in that one is because I was here. I brought it in because of this place.
Okay.
Yes.
Ion.
Yeah, it is ion, but now it is not ion 2. It should be ion 3.
Because it is.
So it is actually ion 3 venye umesema Monica. The only thing that is missing.
Yes.
The only thing that is missing here is what do you call now? It is hydrated. It should be hydrated. hydrated iron 3 oxide. Because iron and oxygen actually forms iron 3 oxide. Sindio?
Yes, yes.
What is missing? What is missing is the water. What are the conditions for rusting?
Water and oxygen.
Yes, that is why you must talk about hydrated iron 3 oxide, so that you take care of the water and also the oxygen in the oxide side. Yeah, so that one is very important. So don't forget, the reason why I mentioned this one is because of the iron 3. I was just touching on that one. Haikuwa maneno mingi hizo. Now we can continue now. So if you add now, we have another one. So we continue now. When you add aqueous ammonia to lead ions, it will form a white precipitate. Please, I don't know, Abdi, mute. So that somebody, I think we should mute, and then I can continue. I'll give you. I normally give out when I ask something, we have to unmute and then we talk. So for now, we can just mute. So white precipitate, which is insoluble in excess. Remember, it was soluble in sodium hydroxide. So ukipewa na inakuwa insoluble, it is still lead ions, but now we have changed what we are changing with. So the inference will change because of the observation. Because of the observation. Now, the one that remains now, that is, so easy vitu zenye munaweza. Now, I normally tell my students that it is very easy. Inakwanga rahisi sana easy vitu kuhandle. It is normally very easy to handle all this because we have 4 that are the same. The observation and the inference is the same. Number 1, iron 2, yote ni green and insoluble in both sides, in ammonia and sodium hydroxide. Iron 3, the same. It is brown or red brown. If you write brown precipitate form, actually you'll be correct. And then it is also red brown in ammonia, and it is insoluble in both. And then zinc is white precipitate, and it is soluble in excess in both of them. So you are supposed to, ukishika hizo, the remaining will be very easy for you to remember. Now, copper is the same. The only difference that come in is insoluble in excess in sodium hydroxide, but soluble now in excess to form a deep blue solution, deeper, a darker. Yeah, so that is the only difference that we get here. I hope that one is okay. So those ones are very important to remember. This one is something that must be there in the exam. Test for anions and cations, lazima ikue. Now, in your practical, it will not be question 1. Most of the time, the practicals actually, we normally give this one as question 2 or 3, where you have to eat something. I will talk about that one. Now, so we continue. We have now the test for gas, a particular gas. Now, what is the result? This one is the conclusion. You see when this one is the conclusion. That is, you are saying, ni kitu ndo iko ndani. The observation that you will be seeing is this one. Now, I don't want to say dump. This one was the idea of a friend of mine who said use dump because he teaches in an international school. So he told me the students in there, they don't talk about wetting the litmus paper. But now in our system, tunasema tunaweka maji kidogo, yeah? You dump. Of course, it is dump. Of course, I just realized that it is correct, actually. Say dump because aina maji. And because when you say wet, it must be having a lot of water. But when you say dump, a damp cloth you cannot wear. Yeah. So, but anyway, so when you add this one, so when you have this one, ammonia, number 1 gas, it turns wet litmus. Please make sure that you have, kama unaweza tumia your damp or wet, where andika wet. Actually, a dry litmus paper is not affected by either an acid or a base. Sijui kama mmenisikia hapo. Wacha nirudie hivi pole pole, kila mtu asikie hivi. Ukiwa kwa lab na wamekuambia test the gas using the litmus paper that you are provided with. Kitu ya kwanza ukiona tu using the litmus paper, kitu ya kwanza ni kuweka maji, mwagia maji ya litmus paper. Wacha niseme hivyo, mwagia maji ya litmus paper na uweke sasa utaste. Now I'll show you how to taste. We'll just watch I don't know if it is possible to watch a video, but if we watch a video, the better. If not, I'll just explain using diagrams. So it normally turns wet red litmus paper blue. So the inference could be ammonium ions or ammonia, yeah, present. Carbon dioxide, it gives a white precipitate in lime water. Of course, when it dissolves in lime water, it will produce a lime water. Now I have to write that one down. Lime water is actually the simpler or the chemical name for calcium hydroxide. So lime water and calcium hydroxide. And this one is something that we used in Form 2. If you go to a topic in Form 2 called carbon and its compounds, utapata hii kitu. You even get the equation that has been written for you, which normally forms a white precipitate. Now, if there is chloride ions, that is chlorine gas, it will bleach. So first of all, now, this one is where I normally come in to explain. The observations for chlorine are normally two, and I'll mention them this way. Ya kwanza, the litmus paper, it does not affect the it does not affect the blue litmus paper. It affects the red litmus. Yeah, chlorine is normally acidic, so it affects the it affects the blue to red, and red is not affected. That is the first observation. Chlorine is normally acidic, so acids affects the blue litmus paper na ina change kuwe red. Alafu, so you are told to test using the two litmus paper. Both, we have two litmus paper actually that we use mainly, the blue and the red. So nimesema ukiambiwa hivyo, the first thing you do is kumwagia maji the litmus paper. Unaweka maji the litmus paper. That is the first thing that you do. And then you introduce. Now chlorine will change the blue litmus paper, and it is very quick. That is why you must be very alert. That is the first thing that we spoke about. You must be very, very alert. Now, so it will affect the blue litmus paper to red, and then now it will bleach the two of them, the red and the blue. Yenye ilikuwa blue ina turn from blue to red kwanza, alafu ikiwa red sasa it becomes white. It is bleached. That is bleaching. And we will talk about, I'm not going to discuss that one. It is the bleaching process of chlorine. We'll talk about that one somewhere. Now, hydrogen, if you introduce, and then it burns with a pop sound. That is the test for hydrogen. Ukiintroduce a burning experience, unasikia inalipuka that way. That one is hydrogen gas. Ukiintroduce splint yenye umewasha na ukazima, yenye inaitwaje? Iko na, it is just red. I know, I'm looking for that name. It doesn't have a flame, lakini iko na moto, but there is no flame. Because we have flames, we have the luminous and there is no flame. Now it will light a glowing splint. It is just glowing. Iko na moto lakini haiwaki. It doesn't have a flame. It will be relighted, so it will form another flame, or in a starter flame. That one is oxygen. There's something that is missing. I'll just mention that one. Sulfur peroxide, we normally use oxidizing agents, which nilikuwa nimesema in titration it happens the same way. So you'll find potassium dichromate 7 changing from orange to green. Potassium manganate 7, which is not here actually, changes from purple colors. So you should not be worried. We'll talk about that. I hope I'm not moving too fast, but I'll still share these ones. I'll still share these ones. Na nikishare tafadhali msome.
Teacher,
Yes.
can I ask a question?
Please do. Yeah. You stop me and then you ask a question.
What is the importance of wetting your litmus paper?
Now, Yeah, that's a very good question actually. So we went now when there is no water, the gases does not perform anything. It requires water for this. Unajua ikiwa gas. Now let me ask you. Let me just ask you, but I'll answer the question. Wewe kwa hewa saa hii, hewa yenye tunapumua now at the moment, do you have nitrogen inside and carbon dioxide and all those shenanigans inside?
Yes.
Now, does it affect us? Tukiwa tu hivi, does it affect anything? Hata nguo ukianika inaafektiwa? No.
Inakausha nguo.
Upepo inakausha nguo. It is not actually the air. Kuna tofauti. Upepo kwa Kiswahili ni wind in English.
Yes.
It is not air. I don't know if,
Yeah.
So yes, so yeah, so it is not yenye inakausha nguo sio hewa. No, it is the wind. Upepo. Yeah.
Yes.
Yes. So actually, without water, the purpose of the water is to dissolve this ammonia gas. Sine gas. Now the gas does not have any effect. Molecules are very far much apart. So you know your maneno ya maji, no liquids, gases, and solids, where we have gases very far much apart. Evo. So the gases will just pass without touching. So we need the water to bring the gas molecules karibu. Yeah. So in a stick up, like a stick now, that is where the reaction will occur. So when water dissolves, for example, ammonia, it will form the hydroxide, OH, which will be now responsible for what? Color change. And happens again with chlorine. It will form hydrochlorous or hypochlorous. Let me just call it HOCl, hypochlorous acid and hydrochloric acid. And then now the hypochlorous is so tunataka hiyo O ya maji. Hizi hazina. For example, chlorine does not have O. Also, ammonia does not have O. Now, the water will dissolve the ammonia, elate what we call ammonium. Now, let me write for you so that you understand. I think when I write it feels better. So, hii ammonia inakaa hivi. Ukiongeza maji inakuwa imeandikwa hivi. So, ukiongeza maji ina form now what we call ammonia ikiwa hivi has no effect. Lakini sasa ammonia ikidissolve kwa maji ina form something like this. And this one is actually taught. Inafunzwa kabisa. That's why Monica, I'm doing it. It is actually taught. Yani kama subtopic. Na nilifunza, by the way, I don't know, people have forgotten. I think I was the one who thought in assets, bases and salts in form 4. Tulifanya salts ya form 4, sina?
Yes.
Iko sasa hii kitu pale tunasema ina affect litmus paper when it is in methyl, when it is in water, but it does not affect while it is in methyl benzene. It affects in water, but it doesn't affect in methyl benzene. So in water, we say it hydrolyzes. So hydrolysis now ni ukiongeza maji na form kitu kama hii. Now this one hydrolyzes, meaning it produces ammonium ions, kitu kama hiyo, and of course it is aqueous because it is a solution now, plus OH. Mnakumbuka tukiandika kitu kama hii? You can go back and check. I think I shared the notes. Yes. So without water, Monica, maji hakuna, hii haiko. And this one now is the one that is responsible for this color change. So maji lazima ikue so that it can hydrolyze to produce those ions. Kila mtu ako sawa. And it happens to all of them. Kama hakuna maji, there is no hydrolysis, so it will not be affected. So usipoweka maji, your observation will be haikufanya kitu. And that one is wrong actually. So anytime you are testing using a litmus paper, wacha tu tuseme hivi. Ukitest using a litmus paper, anything, unless it is a liquid, unless it is a solution. So kama una test kitu unless it is a solution, kama sio solution, weka maji. Si wacha tu summarize hivyo. Is making sense what we have just said?
Yes,
Kama,
teacher.
yes, kama una test kitu yoyote kwa lab, in fact including the practical that you're going to do, I think you're going to do it at the end of this month. Kama umeambiwa test na litmus paper na sio solution, kitu ya kwanza ni mwagia maji hiyo litmus paper. Wewe weka tu maji na useme mimi nilisema inawekwa maji before utumie kutest. As long as you are testing gases that are being produced, unless it is now the what do you call you are testing whether the solution that has been given is an acid, so already it is a solution, so lazima uweke maji, but bado unaweza weka maji, it will still be affected because the other one has water. But for actually for you to check, to observe well, especially when you are testing something using a litmus paper, lazima ikuwe na maji. That is the conclusion we are going to make for today. I was just explaining this one, but if you want to understand it better, you can go to, it is normally in two topics actually. So this one is normally in 2 topics, which I have mentioned one, which is the one that we did the other time. We've done that one, and then this one now is it will be some, I think it is in chlorine and its compound, nitrogen and its compounds also, it is normally there in form 3. That is why you kama tuko sawa.
Iko sawa, teacher.
Yes. So this is how you test these things. This one actually is an experiment that has been done in Africa. In Africa we don't have unaona mkono yenye imeshika kwanza sio yetu. So those kind of things tumewachia wazungu. In Africa we normally shikana mkono. So unaona, now I want you to see what is happening in this picture, so that you understand what I've been mentioning. I want you to see the difference between these two. Now, I want you to see, unaona hii kitu iko na maji kutoka hapa. I want you to check if it has water. The reason I brought this picture is only for people to see. Hii inakaa imewekwa maji side moja.
Yes.
Yes. So we weka maji. Weka tu maji. Now, and then you put it on top. This one has not been even placed on top. So sisi, mimi I normally advise still, unaona venye hii test tube imekaa. Now, test tube normally looks like this. Of course, mine, I should have drawn a better one. I like doing a good drawing. I try, even kata kama ni mbaya, ikuwe mbaya mzuri. Huh? So you have a test tube or a boiling tube, any that you are given. Mostly in the lab, they'll give you something to hold, test tube holder, when you're going to heat those things. Or when you're dropping a solid, sometimes it may produce heat. So it is very wise for you to use. So ukishaweka maji, you have 2 litmus paper, unaweka up. You know now the litmus paper is normally feeble when you inakuwa weak. So unaweka hapa na ingine hapa. Usitupie ndani, some students wanatupia ndani. So weka tu kando hapo. Young, is young tu hapo. Na uchome hizi. If you are kama ni kuhit, you can hit. If it is dropping something, unaweka tu kando. Hata huwezi realize, alafu unatupa. And then you will see something, you just observe something. So if effervescence is observed, of course you don't see the color. You don't say, you can say the color of the gas. That is what you see. So effervescence, gas evolved, which turns. But now the good observation is, it may affect litmus paper edge. So that one. So conclusion, don't write conclusion. I'm not even going to talk about the conclusion now. I'll talk about that one later on. So unaweka kando venye nimeonyesha, especially the litmus paper. Ndio hiyo. These ones are test for carbon monoxide. You are eating something, alafu you pass it through, which is normally, this one is a test tube holder. hii ni test boulder lakini sio yetu haifanani hivyo. You know how ours look like. No? Ni ile yenye inakaa kamata na iko na mbao huko mwisho, but you just open it this way and then unarudisha hivi inashika. It is normally as wrong. So effervescence, so it forms white precipitate with dry mortar. This one is a practical that is not, it is rarely done because of this process, but it is done now in form is it form 2? This one is done in form 2 in the not practical, but we did this one with my students in the practical, but it is normally done in the theory section. So carbon dioxide is produced. You must also wet all of them. Effervescence, so test for chlorine. We are just repeating what we just did there. Now, doi sasa of observation, hydrogen gas, it burns with a pop sound. Mara mingi inazima hiyo light, inazima hiyo kitu yenye ilikuwa inawaka. So that one is number 1. Extinguishes with a pop sound. Itazima juu ya hiyo pop sound. Now, if we are testing nitrogen, we will say it gives negative. It gives negative results for all these tests. Nitrogen actually inatoanga negative results. Haionyeshi kitu, you can't know what is going on. You can't know what is going on. So it becomes very hard. Yeah. So negative, it gives negative results. So we are only testing that one. So this one relies on glowing spring. Unaona ilikuwa inaenda kuzima, alafu inawaka tena. You say now oxygen is evolved. This one we are just showing what is happening. So we have this one that it will from that one. Sorry. Yeah, so I don't know as the mtoto alikuwa amefungua aitwaje the Bluetooth devices and it connects automatically, that's why it's bringing confusion. I hope everybody can hear me now. Hopefully.
Yes, we can hear you.
Yeah. So so I'm saying when you test for sulfur dioxide, which is normally called now, this one is all name for sulfur peroxide. It is now called sulfur peroxide. Yeah, so ukiona sulfur peroxide, you don't say you are not told something. Now, so the observation obviously will be it turns aqueous acidified potassium dichromate. Now, when you're talking about maneno ya the titration, I gave you the color changes that happen especially in the oxidizing agents or those things that undergo reduction. But for now, let us use the simplest term, which is oxidizing agents. And I gave two major oxidizing agents that we have, actually that we use in the in maybe titration or maybe when you're using it in the qualitative analysis, because that one is quantitative, quantity, the numbers. This one is quality, what is inside that tea or what is inside that water. So we have this one is changing from, so I'll write for you the other one. So we have two major oxidizing agents. So which is dichromate, which is changing from orange to green. That is one. And then we have another one that is this one is acidified potassium dichromate. Now kuna ile niliwaambia inaandikwa potassium manganate 7. Called potassium manganate 7. I'll talk about the oxidation stage another time, so you should not be worried. The potassium manganate 7 is normally purple in color. So this one, I just not mention that one, but I normally give out when I'm giving the notes to the students. So it changes from purple to colorless. So ukipewa ingine, you don't say sisi tuliambiwa tu dichromate. It is the same process that happens. It happens when you are dealing with the titration. Pia inafanyika hapa the same color changing from orange to green, and this one also for manganate 7 changing from purple to colorless. Yeah, so don't forget that one. Now, so let me wrap this one. So we have oxidizing agents. Now we have two major oxidizing agents. There's a place where we'll be talking about bromine. I don't want to talk about bromine now, but we normally undergo what you call redox. We have now redox, the oxidation and reduction process. It still undergoes the same. Now we continue. Now before we continue, Monica, Swali,
Yes, sir.
do you have a question?
No question, but maybe clarification.
Yes,
Umesema
Mhm.
umesema wet litmus paper haina
Mhm.
effect yote kwa HCl, kwa acid. Umesema does it have any effect? Maybe tukiwet hiyo HCl. Umesema tusiwet hiyo litmus paper when maybe using nini, or pia ukasema tunaweza wet. So ndio alikuwa nauliza does it have any effect maybe if we wet but kama
No,
umeitumia kwa acid.
no, it doesn't have any effect. Now, what I'm saying, now let me just clarify that. When you're testing using gases, you can never know. Iko sawa mpaka hapo? Because
Yeah,
actually gases cannot
sawa.
react. Now, when
Yeah,
we
but
talk about now in acids, for example. Now, when you are in is it the mole? I think it is the mole where we are saying acids, and actually they have a small percentage of water. You remember tukisema the strongest acid is sulfuric acid, yeah?
yes.
Na nikasema ni 98% sulfuric acid. You remember that?
Yes.
Yeah, na tukasema nitric, I think we said is it 65 or 63%? Around there. Si mnakumbuka hizo vitu?
Yes.
What do you think is the remaining percentage? What do you think is the remaining percentage? Tukisema 98% acid, we have 2%
2%.
nini?
2%.
Yes.
2%.
Yes, the 2% could be what?
Water.
Yes. So iko na maji already. Is it
Already.
making sense now? So
Mm.
it has water already. So whether you add or you taste using, you wet or not, there is no problem.
Okay.
Iko na maji already. Iko
Iko
na
na
maji
maji
already.
already.
Yes.
Okay,
Yes.
sir.
Yeah. So maneno ya solutions, there is no problem. Most of the solutions actually has water, has a small percentage of water. The ones that you're supposed to confirm or to wet, which you must wet. I normally write must in capital. That is why now teaching a practical session, what do you call it? Theoretically, is a little bit tough. I don't know if it is you're feeling the same way, but it is a little bit tough. Mara mingi. I normally feel it is not even on my side. I normally feel for the students, but we are just passing through so that tukifanya practical, at least you have an idea of what is going on. So ndio, I think it is better that way. Otherwise, tungeendelea na the malls. But I thought, see, I told you the other time that when we meet on Monday evening, we'll be discussing about the practical sessions, what you'll be doing in the practical. So I just wanted you to have an idea of what is going on. So if you test for cations, there's no problem. Now, I just wanted to go to where we have a white precipitate so that you see. Now, this picture actually was generated by a computer, but it is actually the same thing that you will see. When you have, now, so test for, you have calcium, lead, and zinc ion. So when you have white precipitate observed, so the observation is a white precipitate is formed, which precipitate I have shortened to be PPT. Lakini nimesema wacha tu nitakuwa narudia hii story because I'm the one using this note, and it is because I'm sharing the screen. Otherwise ningekuwa na, if I was writing on the board, ningekuwa naandika white precipitate formed, not white PPT. Singeandika PPT. So please don't use white PPT. Never. So observation. So we have soluble in excess. When it is soluble in excess, we say now it is lead ions and zinc ions that are present. Remember, this one is how we are testing the ions. So tumefanya huko juu. I'm just showing you. Now, ikiform kitu kama hii, it is white precipitate. I have to draw it so that people. This one, you see this one. This one, ukiona tu kitu kama yani. Now, let me just tell you the way I normally tell my students. Ukishika hiyo test tube na uone ile side ingine, ufunge macho moja na uone the other side na ionekani, it is a mist. That one is a white precipitate. If I can see the other side, you see they have used so that you can see the blue. If you can see this blue, then now it has formed a white, a colorless solution, or it has dissolved. You don't say, you have to say it dissolved to form a colorless solution, or that dissolves in excess. I don't use English. Hiyo nitaachia madam, yeye atawaambia hizo. So, but actually I'll not be marking English myself, but I want to mark the idea that you realize that it was white precipitate and then it dissolved in excess. You don't even have to write dissolved from a colorless solution because kitu ime dissolve imeisha, imepotea. Yeah. So those are very important issues actually to. So now light blue solution insoluble in excess, that one is copper ion. Green precipitate, utaona green yenye inakaa hivyo ukweli, looks like that actually, exactly, even in the practical. Insoluble, so it is ion 2 ions present. Now this conclusion that has been written here, the conclusion, I wanted to change. Previously it was called conclusion, but in these days inaitwa nini? Inference. So when I'm teaching, I don't know, I've never even imagined that I will I've never thought of changing this one. Inference, it is called inference. So inference is ion 2 present, ion 3 present. Now Of course, let me don't mention that one at the moment. Mumeelewa conclusion inamaanisha inference.
Yes.
Yes, it is the inference. I don't know, when you do your exam, they don't ask you to write the conclusion. Today, they tell you to infer. What do you think that could be? Yeah, that is actually what they're asking. Now, so we continue. So red, brown, we have talked about that one. Test for chloride ions, white precipitate observed, so and actual silver nitrate, you just do that. Evo. So we are just repeating the other thing. Now, oxidizing and reducing agents, you remember I just mentioned that one, Ukoju. The oxidizing agent undergo reduction, but they oxidize the rest. The reducing agent undergo oxidation. So oxidizing agents undergo. So before, when you are using it now, aqueous acidified. So we are just touching on those ones. I don't know kama mulielewa maneno ya cations and anions. Now I can promise you that the test for cations and anions will be there in your exam. KCSE, not your engine. So it will be there. It will be there. It will be there. Trust me, it will be there. So oxidizing agent, when it is purple, it's oxidizing agent. This one now is aqueous acidified potassium manganate 7. I had written that on Ukoju. Now it is KMnO4. Don't write potassium manganate 7. Alafu andike O7. Now I know we have not done what you call the oxidation numbers, but it will be there. So to find the oxidation numbers, you will see where the 7 goes. So it will acidified means you have added a small portion of some acid. At as I add 2 drops or 3 drops of an acid, it becomes acidified automatically. Ukiongeza to a few drops of the acid. So it is purple when we started. After it will be colorless, and it will no longer be manganate 7. It will be manganese, and manganese actually is colorless. Now, acidified dichromate is normally orange, and this one is the ionic equation. The green one that comes after is what we call the chromium ion. In a chromium ion, the Cr this one is chromium ions, but you don't cram that one. Please don't cram that one. Just know the color changes. Acidified changing from orange to green. Now, what has happened? It was negative, it can go positive. What has happened? It from negative, going from negative to positive too. Imefanyika nini? I already discussed that one. Imefanyika nini?
Imekuwa nini ya oxygen. The valence of oxygen.
Monica, valence of oxygen is positive too. Hebu ona tena. What is the valency of oxygen? I think I'll bring that topic again.
2.
2 ngapi? Is it 2 negative or 2 positive?
2 positive. 2 positive.
2 negative.
It is positive.
Sorry.
2 negative.
So Abdi saying 2 negative. So it is 2 negative. Actually, it is 2, but it is a negative 2. It is not positive. That's why I wanted. I think I'll come back to chemical formula. There is actually a topic in chemical formula. I think it is chemical formulas patterns. Yeah. Form 2 work. Very dangerous. Very dangerous. So this one has undergone. It is rising. Before it was negative, and then it has gone to positive 2. We'll talk about that one. acidified it was -2 alafu ikaenda 3 positive. Now aqueous ion 3 before, so that one has undergone something else. It was from positive to 2 positive, which was from, now this one is yellow or brown. I don't normally want people to get confused. That is why there's no problem to say yellow inakuanga pia brown. Now this one also, sometimes when it has impurities, it is a yellow, but it's normally dark brown mara mingi. Yeah, but if it is has impurities or it has been exposed, especially if it has been exposed to light, ndio inaharibingi. Light normally destroys everything, so ikiexposiwa to the light inaletanga that problem. Yes, so those ones. We have now displacement reactions. These ones are some of the things that could be formed. We have displacement reactions. Now, in displacement reactions, we normally say a more reactive metal displacing a less reactive. But these ones are questions. Now, what I am doing here today, or what we are doing here today, is we are just predicting what could be there. But let me not go to the displacement reactions today. I want to unshare this one, and then I share something else. I hope that is okay, so that you see what I've been discussing all through, especially when we're talking about cations and anions. So I'm very quickly. I hope I can get it very quickly. So I have a lot of things that can be. I don't know. I want to check if we have a question that has been done, so that we see. I hope this one can open now. I hope it does open. So I wanted us to do a question. Now the only problem with let me see if it opens. I hope there is a question. I don't know if this word can open this. I don't think one can do. Let me just try it. Maybe it will open. Let's just wait and see. I want now us to understand maneno ya iron. Now this one is a confidential, so there is no problem. Confidential, you don't have to know what is there. It's actually, so this one is, that is why I don't normally like using the word most of the time. It normally brings a lot of confusion. I don't know if you can see the screen. Can you? So the first thing that you're supposed to do, of course, is you are provided with. So this one is something else. I'm not interested in that one. I'm not interested in that one. I'm interested in the other part now. I'm interested in this part. I want you to see the part that I'm interested in. Can you see the screen, first of all?
Picha haijafunguka nini, tunaonyesha tu hizo.
Okay. Okay, no problem, no problem, no problem. I'll do this. And then there's something I want you to see. And there's something I want you to see. And so let me move this. I've made something. There's no this. Yes, better. Now, I want you to see what normally happens. Now it is visible, yes?
Yes, yes.
Yes. These ones are the kinds of questions. You see now it goes to question number 3. These ones, some of the questions here, I think I'll give them to you when you'll be doing practical so that you muone some of the things that could be tested. So you are provided with solid X, Y, and Z to carry out the test below. Write the observation and inferences. Now, the conclusion that we're talking about is what we call the inference in this case. Place the solid Y in a clean test tube. Add 10 centimeters of distilled water and shake. And then, ukiadd, so you are supposed to say it dissolves. Ukiadd maji, you say it dissolves to form a colorless solution or it dissolves to form a brown solution, and then you can infer. You say absence of colored ion or colored ions absent. And I've mentioned the colored ion. We will do a practical. Now, divide the solutions into solutions in A above. Hiyo yenye ulikuwa sasa umesha dissolve into 4 portions. So unaweka 4 portions. We normally give you more than 3 test tubes. Utapata uko na test tubes kama 4 ama 5. That is now the work of those test tubes. Unaweka, so the first portion unamwagia about 2 centimeters. Now I normally measure, it is normally very easy to advise students to measure 2 centimeters. I normally tell them to use your hand. Unaona mkono? I want you to just use which one? Is it called the index finger? Yeah, I think it's called the index finger. Now, kwa index finger, kuna kuanga na hiyo nafasi, kuna kuanga na hiyo vitu, tuseme nini, boundaries between the upper side and the lower, the middle one and the lower side. Yeah? Are you seeing those? So, hiyo kitu, there was a student who asked me, sasa mimi nitapima saa ngapi 2 centimeters? Please do not measure. Mwagia kwa test tube ukitumia hiyo kidole. Unaona hiyo nusu ya kidole, the part that is, I don't know the name of those things anyway. So pahali imekatwa katwa, ukiweka mkono hivi, the first finger it has normally vitu kama slits yenye imegawa juu, katikati na chini. It normally has 3. So you pima using the first one. The first one actually is about 2 centimeters. It is not accurate for 2 centimeters, but about. So unatumia hiyo mkono. Yes. And then you place now, the first portion, so the first portion adds sodium hydroxide dropwise until in excess. You see now the kind of portion that will be coming. So if you had sodium hydroxide and then it forms green precipitate, unasema sasa inakuwa nini? That one is ion 2 ions present. That one is the inference. So the observation, for example, let us write, acha niandike moja so that you understand what I'm talking about. Of course, there is something that I wanted us to do, but I don't think we are going to do it. I wanted you to understand my cation first. So, hiyo kitu inakuanga imekuja hivi. I have the answer sheet, but we'll do another example. So we'll have, the first thing is normally observation. Kila mtu anajua. I hope everybody has done a practical before. Yani sio ya kwanza. Yeah. And then we have the inference. Now, hii inference ndo ilikuwa conclusion, but now we call it inference. Now, I normally explain using conclusion to students because sometimes they will tell me, sasa inference ni nini? So you tell them it is the conclusion. What do you think you have just done? Now, I want to answer question number 2. To the first portion, add sodium hydroxide until in excess. So we are adding sodium hydroxide. So the first thing that you're supposed to remember is when you add sodium hydroxide, you start with observation number 1. Umeongeza kwanza. You add first before you added excess. So it forms, for example, I want to use, let us use, it forms a green precipitate. So form, let me just summarize green precipitate form. Na nimesema usiandike hizi vitu naandika. Don't write PPT. I'm just writing because you are summarizing. But this one is written, it forms a green precipitate. I can put a comma. Or you can just write as point form. And then you say, this green precipitate is insoluble. Insoluble in excess. So you must also account for excess. even hata kama umeweka 1 mark kwa observation, juu utapata imeandika 1 mark hapa. I have a mark for saying it forms a green precipitate, and then you also explain when in excess what is formed. So insoluble in excess. So the solution, the green precipitate, hata ujaze hiyo test tube sodium hydroxide I dissolve. The inference now, if you remember, kama unakumbuka ni ion 2, unaandika ion 2 ions na unaandika ni in ion form. Uandiki kwa, I don't know, in English, because ion 2 actually is ion 2. In English it is ion. I'm saying you don't write ION and 2. You write it this way, and then it is now present. I want to explain something. I wanted to do an example literally. Now, kuna time yenye umefika exam room na ukumbuke hata ion 2 ni green, umekumbuka copper ni blue, na ukakumbuka ion 3 ni brown. So you don't remember these others. What do? You don't remember. What do you do now? Umeingia na umesahau, ukumbuki ion 2 ions are the ones that are here. Kitu unakumbuka tu ni copper, na unakumbuka copper ni blue na ion 3 ni brown. Umesahau hiyo ingine. The answer to this one again. So maneno ya inference in conclusion ya chemistry sio kama ile ya what do you call ya when you're writing a story, you have to conclude, or you're writing an essay and then you have to conclude. The conclusion, you can write the wrong conclusion but make it right. This is what I'm saying. So you can say unakumbuka kuna ion 2, ukumbuke ion 2, lakini unakumbuka kuna copper 2 ions that are blue, na unakumbuka this one is 2 alafu unakumbuka pia kuna ion 3. So you remember there is also ion 3, lakini sio green. You can say copper 2 and ion 3 are, unaandika absent. Both of you will have a mark actually. So huyu ni correct, alipata yeye alijua iko, lakini huyu anajua zenye haiko, so pia yeye ako sawa. That is what I wanted to talk about. How are we faring on? Monica, najua uko na swali, so nataka uulize kwanza kabla sijaendelea.
Sasa sina swali. Kwa sawa.
Okay, then we are okay. So both of you, I want you to see now where you might get wrong. Now, something that I'm supposed to tell you, if you wrong this one kwa observation, so uandike yellow na blue formed in yani uandike vitu zako hapa kwa observation na upate hapa ni correct. So if you wrong the observation, that means you are guessing the inference, or you are copying the inference. If you get the observation, so what I'm saying is mtu anaweza pata observation correct na wrong inference, but huwezi potea observation na upate nini inference or the conclusion. I hope that one is okay. Now, and these questions are normally following each other. To the second portion, add aqueous ammonia, dropwise until in excess. So, for example, if you add ammonia to copper, so it normally forms a blue solution, light blue, or you can say blue solution form. Blue solution form. Now we are talking about question number 3. So we say blue solution is formed, and then you put a comma. Nilisema ina dissolve, which dissolve, so soluble to form a deep blue solution. Soluble to form, I don't know now, I want to look for something. So ikidissolve ya kwanza iform something like this. So it will form and then the second one, so I'm looking for, let me use this one. So ya kwanza ina form kitu kama hii. Let me just do this. And then it can dissolve to form a new solution. Utaona kitu kama hii. I think I'll use this one now because we have. So it dissolves to form deep blue. Are you seeing the difference between those blue? That is why I'm saying lazima watu wako very alert. The first thing that I mentioned when we started this one, nilisema people must be very alert. So it will dissolve, a blue solution is formed. That is ukiongeza kidogo. Ukiongeza mingi kabisa ina form a deep blue solution. Now this one is a light blue or dissolves. This one is a blue. So I think a blue solution is formed and a deep blue solution is formed was for men. Because actually men, they are colorblind. They don't know. I don't know. I don't even know light blue. I don't know. Women normally have. I am told there are about 7 blues. It doesn't make sense to me. I don't know if it makes sense to you. I don't know 7. Why would I talk about 7 blues? I just need a blue shirt. As long as it is blue, I'm good to go. And then you bring somebody and then somebody will say, "E blue, sio blue unataka blue. You told me you want blue. I brought you blue." So you're supposed deep blue, different chemistry. Now, so so there are 2 answers to this one. Copper ions. The simplest answer is actually copper ions present, and that one is correct. Now, I think there's somebody who has forgotten which ions are normally blue. Lakini wanakumbuka ion 2 ni green, wanakumbuka lead ni white. You remember everything else that is wrong. Let me use that word. Unakumbuka kila kitu hapa yenye ni wrong. So what do you write? You write the wrong but make it right. So you say ion 2 ions alafu lead ions, which you know it is white, it can dissolve. You can write another one, even aluminium, even zinc. Unajua zinc hata ni wewe unakumbuka zinc ni white, lakini yenye ni blue kumbuki. Unaandika these ions, lead ions, zinc ion aziko. So you write those ones are absent. Actually, both of you will score a mark. So huyu anajua zenye aziko na huyu anajua yenye iko. So everybody scores a mark. This one takes care of everybody. Kama sasa tuko sawa. I wanted actually I was interested in this one more. Tuko sawa. Do I have to add anything else to this one? But this is the method of testing the ion. I know I've not typed on those ones that are testing cation, but I have to do it again. But I don't think I'm going to do it today. But I wanted people to understand how it tastes cation, especially the infant. Nani ako na swali? What was the question? Have you understood?
Just clarification.
Yes.
Yeah. Kwa hivyo, when answering this question, you should use that table.
The table that I left is correct. But I think there's a better one. There's a better one in word form. I don't want to send you this one. I want to send you another one. But I think I left it. I normally have another computer in school that we use. I think it is in that one. So I'm going to confirm before I send you the ones that I was doing. You want to me a clearer one, which is easy to. Even if I don't get that one, I have those notes in hard copy. So nitapiga picha to that first, alafu nitume. I must send it tomorrow so that you use that one in the meantime. Especially what you call the test for cations using sodium hydroxide and ammonium hydroxide. I'll share that one tomorrow. A summarized one, which is better than this one.
Okay.
Yes. So unless there is a query, I don't know. I don't think I'll continue. I don't even think I'll start another something else that I wanted to touch on, but I think it should. I still share that one. Alafu we do. That's why I was saying this actually teaching a practical session. Now mfanye practical. I don't know. I normally feel for the students. So I wish I could share this one. Let me check this one. I have a lot of them, so sometimes I don't know if this one is okay. Let me just confirm so that you see what I'm talking about. This one is a practical that has answers and questions. I don't want to confuse you even more. I want something that is direct, yeah? That I don't have to. I'm just checking. No, I'll not give you this one. I'll give you this one after you're done with that one. So I'll give you this one when you're done so that I don't bring more confusion. I don't like to confuse students. I say near it pole pole and everybody understands something. And then me introducing 3 concepts or 5 concepts at the same time, and then you get confused all through. That is why I wanted you to understand cations and anions. But anions, you're going to touch them more, or I can still share the PDF, and then you check. Yeah. So unless there's a query, I want to end there for tonight. I hope you have to wake up again for another class in the morning. So unless there's a query or a very serious question, especially touching on what we just handled today, if you have another question, of a question that is touching another topic, that is still okay. Iko kweli? If there is none, why don't I wish you a very good night? I think we'll see. I'll share them tomorrow. Let me just. I wish to get all the notes of that one so that when I'll be teaching, at least you'll be having already an idea. Because mara mingi nalisema vitu zingine. Yes. Abdi, you have something to say?
Yes.
Yes, please.
But hii question ya side ya mole, kuna hii swali ilikuwa nauliza how many atoms are there in mambo ya oxygen hiyo.
Yes.
Alafu the mass of oxygen inakuwa 32 gram
32, yeah, 32.
Sasa kwa hiyo swali sasa hiyo 32 gram sisi kuona mahali imetumika, walikuwa tu wanasema ile ulikuwa nimefuatilia hiyo video hiyo 2 gram alafu times 6.023 times 10 raised power 23 peke yake, na hivyo ndio anza, lakini hiyo 32 gram haikutumika hiyo mahali, ndio nilikuwa nauliza.
No, it must be used somewhere. Now, when you talk about there's something I know. I've understood your question. You're talking about the what do you call Avogadro's constant, and we are talking about 32
Yes.
grams. Now, oxygen exists. First of all, let me just mention it. Oxygen exists normally as a molecule. Now, one atom of oxygen has that actual amount of atoms or particles. We normally say it has 1 mole of a substance has that actual number of particles, which is the Avogadro, which is 6 by 0.023 multiplied by 10 raised to 23. That one is okay, fast, pack up. Now, when we have a molecule, 1 mole of oxygen molecule, 1 mole of O2.
Yes.
But now remember the condition. We'll call 1 mole of a substance has how many particles? It is 6.0. So 1 mole of oxygen molecule ni 1 mole of oxygen molecule. Sio 2 moles ama nile tu. What happens is it cannot exist as an atom. So tukiongelea atoms, oxygen ikiwa na 16 bado iko na hiyo amount. Tukiongelea ikiwa molecule bado iko na the same amount because it is only 1 mole. I don't know if it is making sense.
On-
Yeah, so you
Yes.
might not even have to use it 32, but you can say it is 1 mole of oxygen molecule.
So the two hiyo situmii
Yeah,
hiyo
you might not
the
use
2
it
gram.
because we cannot use it, Abdi, because we are saying it is 1 mole. Remember your condition is 1 mole. I don't know. I think I should this question. Can I answer this question another time? Because I'm feeling that I must, if I have to explain it to Nafika 10:30. Are you okay?
Yes, yes, sawa. No problem.
Now, Maura and Monica, because I have to.
Yes, sir.
Me, I'm
Can
okay.
I? Okay. Let me just explain that question and then we will leave it at that for today.
Okay.
Let me just open a new whiteboard. This one now is out of the topic that we are discussing. This one is the topic that we discussed previously, which is the mole. Let it open first. Now, let me explain it this way. This one is very simple. That is why I like writing when I'm explaining this kind of things. Now, 1 mole of a substance, we said 1 mole of a substance equal to 6.023 by 10. Everybody can see this whiteboard?
Yes.
Yes.
Okay, 23 particles. Now, the reason I'm using the particles, the word particles, I'm using the word particles because of now the person I'm supposed to explain to. Okay, he's back. Please don't leave fast. Don't leave. Let us just finish. So 1 mole of a substance has that particle. Now we have atoms. So when it is 1 atom, for example, which is in this case we are saying oxygen, it is 1 mole of oxygen atom, 1 mole. So it is 1 mole of oxygen atom. Sasa ikiwa oxygen peke yake, oxygen atom. So when we have 1 mole of an oxygen atom, bado itakuwa na this number of particles. As long as you're talking about 1 mole. Iko sawa mpaka hapo? So itakuwa
Yes.
na bado 6.023 by 10 raised to 23. So bado tu iko hivyo. Positive 23, not negative. So bado iko hivyo. Now, it is 1 mole. That means it is 16 grams ikiwa hapa. So we must also take care of 1 mole. But we know that oxygen and some of the other gases actually does not exist as an atom. So it is normally 1 mole of a molecule of O2. Now, and this O2, the mass is no longer 16, the mass is still 16. 1 mole of oxygen, it is like saying what O2 ikiwa hivi peke yake, mass yake ni 32 grams. So what you are saying is you saw somewhere. Now let me just talk with Abdi. You will explain what you are saying. Abdi, you are saying walisema oxygen iko na 32 grams lakini wakasema particles zinafanana. If I understood your question well. Iko
Yes.
hivyo. Walisema mass ni hii lakini wakasema tena iko na particles kama hii. Si ndio?
But the 2 haikutumika mahali yote.
Haikutumika mahali yote. So the mass actually is only changing, but we are still remaining with what? I want you to see this. It is still 1 mole. Na hii pia ni 1 mole. So we do not care actually about the mass. The mass is only used when you are doing the number of moles, especially in the reaction. That takes place in the reaction, but the number of particles are maintained. Sijui kama iko sawa?
Yes.
Yes. So particles zenye ziko kwa 1 mole, whether the mass is changing. That is why. Now I can explain it this way, Abdi. Okay, mass ya oxygen ni ngapi? 32, si ndio?
Yeah.
Lead mass yake ni 207. 1 mole of lead actually is 207 grams.
Mhm.
Lakini iko na particles ngapi pia?
6.0.
Hiyo tu bado. Kuna ingine
Yeah.
hata sodium iko na 23 na bado iko na particles ngapi? Hizi. Hydrogen
6.0.
iko na yes. Hata hydrogen mass yake ni 1 na bado particles zenye ziko naye ni ngapi? Hiyo.
That's 6.023.
Yes. Is it making sense now?
Yes.
You don't check the number of the atoms that have been combined, especially when you're talking about molecules. Please check the number of moles. Now, if I introduce this one to be 2 moles of oxygen molecules, this one changes automatically. It is no longer 6.023, but I multiply this one by 2.
2.
Yes. When it is 2 moles, so we take care. Sisi tunashughulikia tu kitu yenye iko mbele, wachana na hii yenye iko nyuma hapa chini, sawa? Unawacha yenye iko chini, just check on what is starting for that. I want to just to touch on that one, but this one is a very good question actually. I think I'll still repeat this one somewhere. We can still do it somewhere else. Iko sawa Abdi? Is it better now?
Yes, yes. Thank you.
Yeah, you're very much welcome. So tutakuwa tunasaidiana. If you have a question that is touching that nina nasemanga hata kama topic haiguzi wapi, doesn't touch the topic that we are at that time, I'll always try to answer you. Yeah. It is better to tunaongeza even 10-20 minutes, but you get the point. Like now, Abdi, I know you will sleep well now. Yes. So
Yeah.
now that you prepare, maybe those who have taken supper, like me, I take supper and then you can. If you have another question, just do. I still reply to everybody. You can chat me on WhatsApp. If you call me, I still pick your call if I'm within reach. Yeah, otherwise, there is nothing else. We can just
Teacher, no assignment.
yes.
No assignment today.
There's no assignment because I want to give you something. I want to give you the things tomorrow, and then I post the assignment, which will be better. Now the only problem with this, Monica, I think I didn't mention the only problem with this one is so you don't know how to give out an assignment because the assignment is I wanted you to do a practical. Yeah,
Yes.
ufanye hivi alafu uniambie umeona nini. That is the assignment actually, which it is not possible at the moment. But I think I can cook something because now you're supposed this one is actually was an experimental. It is an experiment one. But sisi tumefanya kama nini? Theory. You see now the problem? So that is the only problem that came in with this one. Otherwise it would have been good kama tungeweza kufanya experiment. But I still share the one tomorrow, and then now you can predict the question.
Okay.
Okay. Well, if there's no other question, I think I can say good night. Have a very nice week because they're starting the week. And I thank God that the rain hata haikukuja, ilikuja tu kidogo, but it was not loud. I don't even think that you realize that there was rain. So ilinyesha lakini haikukuwa that loud. If there is no other query, I wish you a good night and have a very nice supper. Bye-bye.
Good night too.
Good night.
Good night.